Hi there. So in this video, we will take a look at a particularly boring and dense passage from the OG. So this is passage with question number 63 to 68 if you're referring to the OG 13 or 2015, and 66 to 71 if you're referring to OG 2016. So let's start reading through the passage. As always, we will first read the passage, understand it in great detail, and then we will predict the purpose of the passage, and then we will look at the questions. So the first sentence of the passage is always very, very important. It says, Milankovitch proposed in the early 20th century that the ice ages were caused by variations in the Earth's orbit around the Sun. So I know the passage will be about Milankovitch's theory and about ice ages. And the first sentence tells me that according to Milankovitch, he is giving a particular reason what led to ice ages, variations in the Earth's orbit. For some time, this theory was considered untestable, largely because there was no sufficiently precise chronology of the ice ages with which the orbital variations could be matched. So the rest of the first paragraph basically tells us that for some time the theory was considered untestable. From that you can easily infer that eventually it will be tested or it was tested. That's the meaning from there, because for some time it couldn't be done, which means eventually it was done. So that's something I have gathered from there, which also tells me or gives me an idea of what's going to happen later in the passage. Most likely I will be told how Milankovich's theory was tested and whether it was proved right or wrong. At least that is what I have predicted in my mind, so that helps me focus on the passage as I read on. The second paragraph says, to establish such a chronology, it is necessary to determine the relative amounts of land ice that existed at various times in the Earth's past. So I'm just, in case I'm not clear on what chronology is being spoken about, I can quickly go back and check the last sentence of the earlier paragraph. It's basically, we don't have available with us the chronology of the ice ages. When did the first one occur? When did the second one occur? The timeline we don't have. So the first sentence of the second paragraph says, to establish such a chronology, what chronology? The chronology of the ice ages. To establish such a chronology, it is necessary to determine the relative amounts of land ice that existed at various times in the Earth's past. A recent discovery makes such a determination possible. Relative land ice volume for a given period can be deduced from the ratio of two oxygen isotopes, 16 and 18, found in ocean sediments. So all I've understood is by looking at or by comparing these two isotopes, I can figure out how much ice was there at a particular time on Earth. That's all I've gathered. Almost all the oxygen in water is oxygen 16, but a few molecules out of every 1000 incorporate the heavier isotope 18. Okay, so most of water is oxygen 16. When an ice age begins, the continental ice sheets grow, steadily reducing the amount of water evaporated from the ocean that will eventually return to it. Okay, whatever. Because heavier isotopes tend to be left behind when the water evaporates from the ocean surfaces, the remaining oxygen water becomes progressively enriched in oxygen 18. So all I've gathered is when an ice age begins, because of whatever they have said, which I didn't bother understanding, the amount of oxygen or amount of isotope 18 in water increases, because it is the 16 isotope that evaporates mainly, the 18 gets left behind. The degree of enrichment can be determined by analyzing ocean sediments of the period, okay? Because these sediments are composed of calcium carbonate shells of marine organisms, shells that were constructed with oxygen atoms drawn from the surrounding ocean. So by comparing these ocean sediments from the period, we can figure out how much oxygen, that isotope 18, is there at any particular time, from which we can gather whether how much ice there was at that particular time. I think that's what it is. The higher the ratio of oxygen 18 to oxygen 16 in a sedimentary specimen, the more land ice there was when the sediment was laid down. So, okay, now looking at the second paragraph overall. So what I have deduced from the second paragraph is that the reason the theory, Milankovich's theory, couldn't be tested earlier is because there was no way of finding out how much ice there was at any particular time on land. Eventually, it became possible to find that out by using or by comparing two of those oxygen isotopes, 16 and 18. And what I have then gathered is the more oxygen 18 in the ocean sediment, the more ice there was at that particular time. That's basically the important thing. So based on the study of ocean sediments, I can figure out when the ice age took place and when there was no ice age, depending on the concentration of that isotope 18 in the sediments. So that's basically the second paragraph for me. The third paragraph now says, as an indicator of shifts in the Earth's climate, the isotope record has two advantages. So I'm now looking for the two advantages. First, it is a global record. So whenever I read an advantage or any such thing, I always focus on the first sentence, which is, in this case, it is a global record. So first, it's a global record. There is remarkably little variation in isotope ratios in sedimentary specimens taken from different continental locations. Second, so what's the second reason? It is a more continuous record than that taken from rocks on land. So the first advantage is it's a global record. Second, it's a more continuous record. Because of these advantages, sedimentary evidence can be dated with sufficient accuracy by radiometric methods to establish a precise chronology of the ice ages. The dated isotope record shows that the fluctuations in global ice volume over the past several 100,000 years have a pattern. An ice age occurs roughly once every 100,000 years. These data have established a strong connection between variations in the Earth's orbit and the periodicity of the ice ages. So basically, in the third paragraph, I'm being given two advantages of using this isotope model. And finally, it concludes that based on the isotope model, there seems to be a very strong correlation between the ice ages and the variation in the Earth's orbit, which basically supports Milankovitch's theory. If you've forgotten, Milankovitch's theory in the first paragraph was that the ice ages are affected by variations in the Earth's orbit. Okay, now we come to the last paragraph. However, it is important to note that the moment I see a however, I know a contrasting thought will come now. However, it is important to note that other factors such as volcanic particulates or variations in the amount of sunlight received by the Earth could potentially have affected the climate. The advantage of the Milankovitch theory is that it is testable. Changes in the Earth's orbit can be calculated and dated by applying Newton's laws of gravity to progressively earlier configurations of the bodies in the solar system, whatever. Yet the lack of information about other possible factors affecting global climate does not make them unimportant. So the last paragraph, basically, the author is saying that while this particular isotope theory looks good, there can be other explanations also. It's just that this theory is the easiest to test, but just because the other possible factors or variations cannot be tested does not mean they do not exist. So he's just basically saying don't get carried away by this particular theory. There could be some other explanation also for the ice ages. So if I have to summarize the entire passage now, the entire passage talks about a particular theory proposed by Milankovitch of what leads to ice ages, and that there's a correlation between the ice ages and variation in the Earth's orbit. This theory couldn't be tested for a while. Eventually, it could be tested based on the study of isotopes 16 and 18. The more isotope 18 in ocean sediment, the more ice on land at that time. Then there are two advantages of this theory. And finally, the theory shows that there is definitely a correlation between, a strong correlation between the occurring of ice ages and variations in Earth's orbit. So that is until the third paragraph. In the last paragraph, the author just mentions that there can be other possible explanations also for this variation. So that is the entire passage for me. If I have to predict the purpose, until the third paragraph, it was absolutely mostly neutral. In the last paragraph also, I won't say he's going on either side. He's basically staying neutral actually by telling you that don't get too excited about the theory. It may be wrong, it may be right, but it can be tested. So I think overall the author is definitely on neutral grounds. So keep in mind when you read a passage like this which has a lot of complex details, especially say in the second paragraph, you saw when I read the entire second paragraph, the way I summarized it, I eliminated most of those details. But I have read them once. If there's any particular question that requires the knowledge of those details, I will go back and read it again. So that's basically the way to approach passages which have a lot of complex terms. Now we will look at the questions. The first question, which is number 63, in the passage, the author is primarily interested in doing what? The global question, like your main purpose. So let me look at the first words: suggesting, introducing, emphasizing, presenting, initiating. Well, I would eliminate suggesting and initiating. I don't think it has either of those two. And I'd look at B, C, D now. B says introducing a new research method that calls an accepted theory into question. Nothing is being called into question. So B is out. C says emphasizing the instability of data is absolutely wrong. So D should be the answer. Presenting a theory and describing a new method to test that theory. That's perfect. He presents Milankovitch's theory in the first paragraph and describes the isotope 16 and 18 method of testing that theory. So D should be the answer to the question. But see how I eliminated A and E just by looking at the first word, because nothing is being suggested by the author and nothing is being initiated by him either. It's a neutral passage. We are looking at question 64. So the question says, the author of the passage would be most likely to agree. So the use of most likely tells us that it's an inference question we are looking at. So the author of the passage would be most likely to agree with which of the following statements about the Milankovitch theory. So option A says it is the only possible explanation for the ice ages. The use of only immediately tells you to eliminate this option. Remember, in any RC inference question, you should never go with extreme options. So only is immediately out. B says it is too limited to provide a plausible explanation. The author never thinks it is too limited. That's again extreme. C says it cannot be tested and confirmed, but it was tested. The passage clearly says it was tested, so C is also out. D says it is one plausible explanation, though not the only one, for the ice ages. That is perfect, because the author does tell you in the end in the passage that there could be other explanations also, or that this particular explanation does not explain everything. So D is very, very good. The language that is used is very good. E says it is not a plausible explanation for the ice ages is totally wrong. The author does believe it is a plausible explanation, just that it may not be the only one. So D definitely is the answer to our question. We are looking at question 65. So the question says it can be inferred from the passage that the isotope record taken from ocean sediments would be less useful to researchers if which of the following were true. So okay, it's an interesting question. Because it says in which of these cases would the ocean sediment be less useful. Right now it was very useful, and I think the answer would connect to one of those two advantages, I think. But let's look at the options. The first option is it indicated that lighter isotopes of oxygen predominated at certain times. So how would that be less useful? I think it will be good, because based on the isotope breakup I can make out how much ice was there at what time. So A doesn't answer my question. B says it had far more gaps in its sequence than record taken from rocks on land. That is the answer. If you remember, the second advantage was that it's a more continuous record compared to rocks on land. It specifically mentioned rocks on land. If you have forgotten it, go back in the passage. I remember it being there somewhere in the third paragraph. It is in line number 37. You see, it actually mentions rocks, which is why the moment I saw rocks in option B and the gaps, it immediately told me that has to be the answer. So B is of course the answer, because the advantage of ocean sediments is that it has fewer gaps compared to rocks. If it had more gaps, then what's the point? So B should be the answer to the question. C says it indicated that climate shifts did not occur every 100,000 years. Doesn't make any difference. It would still hold. So D says it indicated that the ratios of oxygen 16 and 18 were not consistent with those found in fresh water. But fresh water is not our concern. We are okay with ocean water. E says it stretched back for only 1 million years. Even that's okay. Whatever time period it goes back till, at least for that time period, we can get some information. So B definitely would be the answer to this question. We are looking at question 66. So the question says, according to the passage, which means it's a detailed question, which of the following is true of the ratios of oxygen isotopes in ocean sediments? Okay, let's go through the options. A says they indicate that sediments found during an ice age contain more calcium carbonate. Absolutely not. Sediments found during an ice age will contain more concentration of that isotope 18, but not contain more calcium carbonate. So A is wrong. B says they are less reliable than the evidence from rocks is totally wrong. They're actually more reliable because of less gaps. C says they can be used to deduce the relative volume of land ice that was present when the sediment was laid down. That is absolutely your answer. That is what is happening. D says they are more unpredictable during an ice age. Nothing in the passage to say that. E says they can be used to determine atmospheric conditions. Nothing in the passage to suggest that. So I don't need to read any of these options beyond a certain point. C is straight away is the answer because it perfectly matches what the passage is saying. We are looking at question 67. So the question says it can be inferred from the passage that the precipitation formed from evaporated ocean water has. Now this is interesting. I will make a prediction before I go ahead. So you see, it's talking about evaporation of ocean water. If you remember from the second paragraph, you should remember rightly, when water evaporates from the ocean, which of those isotopes evaporate more? It is isotope 16, the lighter one, that evaporates in higher quantity. So I'm guessing the answer would be that this precipitation that is formed will have more of isotope 16 in it. That's what I think should be the answer. So A says it will have the same isotopic ratio as ocean water. No. As I said, it will have more of isotope 16. Less oxygen 18 than does ocean water. That is absolutely correct because oxygen 18 does not evaporate so much. So B should actually be the answer. C says less oxygen 18 than has the ice contained in continental ice sheets. Why should it have less oxygen 18 than the ice? It should have the same amount, right? No, C shouldn't be the answer either. D says a different isotopic composition than has precipitation formed from water on land. We have no idea. E says more oxygen 16 than has precipitation formed from fresh water. Again, we have no idea. B should definitely be the answer to your question. We are looking at question 68. So the question says it can be inferred from the passage that calcium carbonate shells. So what can we infer about calcium carbonate shells? Let's see. A says are not as susceptible to deterioration as rocks. I can't recall anything on those lines in the passage. B says are less common in sediments formed during an ice age. I don't think that's there either in the passage. C says are found only in areas that were once covered by land ice. Nothing in the passage to say that. So D says contain radioactive material that can be used to determine a sediment's isotopic composition. Does it say that these carbonate shells contain radioactive material? I'll quickly go back and check. Okay, the rest of it says which is used to determine the isotopic composition. I don't think there's any radioactive material that's being used to determine the composition. It's just the concentration of isotope 16 and 18. So I don't think this should be the answer either. E says reflect the isotopic composition of the water at the time the shells were formed. That's absolutely correct. That is basically what the passage says in the second paragraph, that whatever was the condition of the water, the same reflection or the same idea can be had from the sediments or these calcium carbonate sediments that are obtained from different time periods. So E should be the answer to your question.